Okay, now that MFM should be set up, in MATLAB, we'll create our first script. So within the main directory, let's go ahead and create our first script. So let's just title it main underscore, my first script or something like that. And we'll go ahead and open it. So I would typically start off with the usual MATLAB preamble, and then let's go ahead and begin some MFM. So let's go ahead and create an array named A, and let's create a uniform linear array of, say, 8 elements. So with MFM, it's as simple as that one line that will create an array. So if we look at the variable A, it's an array. It's got 8 antennas. It's got these coordinates. Recall that an array by default is created along the x-axis, which is why x and z or y and z are all zeros, whereas the x coordinates are something non-zero. Then we have the weights that we can apply to each array element if we wish, and then we have a marker for displaying each of the array elements. So if we want to view that array, we can just use a.show3d, and we have our uniform linear array created along the x-axis, as we said, and they're half wavelength spaced by default, recall, and it's centered at the origin by default also. So there's our array, and of course we can, this is in 3D, so we can visualize all the elements as we wish. And let's go ahead and also, this should be close all. Let's go ahead and look at the array response, or the array pattern rather. So to do that, we can just do show array pattern, and it will display a window like this where we have 4 different plots. And on the left side we have the azimuth cuts, so that's at a fixed elevation, and then on the right side we have the elevation cuts, which are at a fixed azimuth. So in this case we have a uniform linear array, so it's just a function of azimuth angle, and the gain is not or phase of elevation angle. So of course we have a gain at broadside, which is 0 degrees of the array, and that's a maximum linear gain of 8 because we have 8 elements. The array response, recall, is normalized to the number of elements rather than to 1, as is commonly done sometimes. So if we want to steer this array, we can do that. So let's say we want to steer it in 30 degrees. So we want the maximum gain to be in 30 degrees. This can be done in multiple ways. The simplest is to just do conjugate beamforming or a matched filter. So let's go ahead and close that. And we can do that in a few different ways using MFM. The way I'll do it now is to simply get, let's say, R, which is the array response. Let's get it at our direction of interest. So if our direction of interest was 30 degrees, that's pi over 6. So we can get the array response, which is a vector in the direction of pi over 6 in azimuth and 0 degree or 0 radians in elevation. And if we run that, you can see it returns the array response, which is the response at each element in that given direction. So we have R, our vector R, and if we want to set the weights of the array, we can do that using the setWeights function. And then to beamform toward pi over 6, it's as simple as setting the weights to the conjugate of R, and we can do that using that line. And then to now view the array pattern, we will again call show array pattern. So let's go ahead and run all this, and what we get now is an array steered toward 30 degrees as we wished. So this is just a quick first script to introduce you to MFM, to confirm that it's working and to kind of show you the capabilities of the array function. In the next tutorials we'll go over more advanced usage and get you familiar with the other features of MFM.